Awesome. All right. Thanks, Matt. Much appreciated. Hey, everybody. My name is Dan Meyer. I'm the Chief Marketing Officer here at Versa. With me is JT, John Taylor, our Director of Security. So thanks for joining us today. We're really excited to be here. For our session today, we want to talk about an extended vision for the role of Zero Trust in your enterprise. So what we want to think about is, when I first started to look at this, I wanted to figure out where are we in terms of Zero Trust implementation, right? And so what I took a look at is I was trying to look for some data on where people are, right? And what I found was this data from Cyber Risk Alliance that says about 25% of organizations out there are currently implementing some kind of Zero Trust solution. And another 65% or so are maybe kicking the tires. So there's a lot of people playing at it. I'm not sure that there's a ton of people who have kind of finished executing their Zero Trust implementation. So, but there's also not a lot of data on this. So one of the things I just wanted to call out is we've actually created a survey and dropped it into the Slack channel. If you want to take a look and actually put in your own organization's state of play and enter your a little bit of information about this, we'll share the results back out and tell everybody not only where is everybody, at least in this Zero Trust community today, in terms of their implementation journey, right, in Zero Trust, but also what products are they using, right? That's another key thing, right? That's always very interesting. So, who's using what products? It's always a great question to ask each other. And then we'll see what, we'll be happy to share that data out. So jump onto the Zoom and fill out that survey if you get a second. All right, so let's move on. Historically, one of the things that Zero Trust has gotten a big boost from employees who fled the office during the pandemic and started to work remotely, right? And we've all been talking about that today, and it's very clear. If you look at some of this data, you can see a dramatic increase in remote work in 2022. But as we move through 2023, employees are now returning to the office, right? And many of them are now working in more of a hybrid model, meaning that part of the time they work in the office and then part of the time they work remotely. Right. And I would argue this is becoming almost a permanent change in the way we work. Right. And so there's some implications for this in terms of Zero Trust. Right. If you think about it, let me keep moving these slides here. Am I frozen? There we go. Sorry about that. There we go. Historically, organizations have used VPNs to support remote work, right? As the pandemic hit, we started to see a lot of the challenges with this VPN approach as we started to load it up with a lot of users, right? So one-time authentication approach for network access. There's no real way to understand if a device accessing the network might have been compromised. There's no, once you get in, there's a full network or VLAN access based on this implicit trust model as you get into the network using VPN. And so for all the reasons, and then there's scale issues and other things too, but these are a lot of the reasons why generally you see organizations now starting to move to replace VPN with a Zero Trust network access solution. Right? With this approach, organizations are able to replace implicit trust that a VPN model provides with an explicit trust model for network access, right? For your remote workforce. And so as we've been talking about today, the security benefits of ZTNA are things like continuous verification, right? Device posture monitoring, user behavior monitoring, so you can identify if there's a compromised device that might be getting on the network and do something about it. Least privilege access, so your users only access the resources they need and nothing more. And the ability to have a dynamic access control so that when situations change, you can actually change the level of access that people have to your network, right? And so if you remember the statistics that I flashed at the beginning of this section, this allows us to apply Zero Trust for about 28% of the organization, right? And then 52% of the workers are hybrid, right? But what about the rest of our company? There's a big elephant in the room here, which is Zero Trust is a great security model, but today we're really only using it for our remote workers, right? The question is, if it's such a good, and it's the future of security and the way we want to do network access, why aren't we using it more broadly for all of our employees and workers? right? And so that's the question we want to talk about today, JT and I. So if you take a look at the difference here, right? When we say the network perimeter has gone away, for on-site workers, this isn't really true. Our branch and campus offices are still, a LAN, local area network protected by firewall access control. And the problem with NAC is that, similar to our VPNs, it's based on this battled traditional implicit security model, right? This means that we're using this weaker implicit trust model for up to 70%, 72% of our workers, if you combine both the on-site and hybrid workers who are working on-site at some point, right? In addition to this, there's another implication, which is we're maintaining two separate security stacks for network access control inside our organization, right? And that's painful from a cost and a complexity perspective, right? So let's take a look at what that means in terms of some of the pain points, right? So there's significant challenges by maintaining these two parallel security stacks, right? First, using an implicit trust model for over 70% of our workers means that our security is weaker than it could be or should be, right? Because we know that an explicit trust model is the right model we want to move to. Right now, getting there, what the evolutionary path to get there is, we'll talk about that as we go through this session. But today, right, if we're just using NAC and implicit trust, that's not the strong security model our vision is where we want to get to, right? Maintaining two parallel security systems is also expensive, both from a licensing perspective as well as a staffing perspective, right? And finally, there's a real huge level of complexity involved in trying to maintain a consistent set of security policies across different products that have fundamentally different approaches to securing access, right? And so it really begs the question, why can't we use zero trust for on-site access control? Right. And so to help answer that question, let me turn the controls over to my colleague, JT.
Thanks, Dan. Really do appreciate that. So a couple things, right? When it comes down to NAC versus ZTNA in the LAN, it doesn't matter, right? If you're using, a true NAC solution, right? You're going to start seeing, I'm going to kind of bridge into what, ZTNA from cloud providers and things like that have as well. But to really look at a true traditional NAC solution, right, versus what ZTNA is, Dan talked about the implicit side of this, right? So, and the implicit side is more of the security comes at a layer 3, layer 2, layer 3, maybe even at a layer 4 type model, right? But the other thing that you have to look at too is that I'm getting access to the network. I'm not necessarily just getting access and explicit access to my applications and things like that. So when I look at the differences between NAC versus ZTNA, right, number one, implicit versus explicit, right? Your authentication, right, in the context it's being used, normally that is a lot of user identity and device identity. Some NAC solutions can utilize some type of context, right? Maybe they have a registry entry or something like that on the end device, right? But when you really look at a true zero trust network access solution, right, you're not just using that user and device identity and some of that little context, right, that we can garner. We're really looking at the true device posture. We're looking at the target application, right, in which you're trying to access, right, location and time for that, right? Maybe I'm in an office that may be classified as in, a non-friendly territory or something like that. I'm overseas, something of that nature. Maybe I'm looking at the times, right, that, I'm trying to access, whatever application that is. But the big thing is I'm actually looking at the target application in which I'm being mapped to at that point. The access control, like we just talked about, right, it's level 2, layer 3. The application layer is where zero trust network access really comes in to give you that access control. Granularity, VLAN versus the application itself. We put in VLAN, right? There is layer 3, that is out there as well. I just talked about that from some of the security side of the house. But realistically, we're still looking at this from a network-based solution, right? We're not necessarily looking at obfuscation, right? Looking at the application itself and saying, how do I map you to that? A couple other big things to look at on this slide, right? Layer 3 access control list, right? Versus software-defined segmentation. That is what zero trust network access really does bring, right? A ZTNA solution within the LAN does bring software-defined segmentation, right? Moving forward. Other things you'll start seeing too is on the performance side, right? Fast switching. I'll get into a little bit of what that architecture looks like from an ASIC side, right? And get into some technical stuff. But we are moving from an ASIC based, fast switching model to really kind of doing the software defined LAN, right? And bringing in more of that software defined security. So kind of move forward. So implicit trust, right? The infection blast radius, right, really does become expansive. And so let's say I have a user that comes online, right, in a traditional sense of a LAN WAN architecture. This user is connected to the switch, right? They can access everything across the board. Let's say that user also is authenticating via a NAC, right? Once again, I'm an authenticated user, right? I'm an authorized user. My name is John Taylor. I work at Versa Networks, right? I can get on no problem whatsoever. What happens if I come onto the Wi-Fi as well, right? Because normally when I'm looking at Wi-Fi, I'm looking at user credentials, certificates, something like that. The problem is notice how all this traffic is still going across the same L2, L3 infrastructure, right? We're really not doing anything that is targeted. So if that device is compromised in some way, shape, and or form, right, the blast area is limited to, right, the entire office or the facility or whatever that I'm in. I'm really depending on my firewall, right? I'm really depending on that device, right, either sitting next to the WAN or to the internet to be able to block the malicious traffic in some way. Now I have to remediate that entire location. And if I have something that is east-west, I'm going across an MPLS or something like that, in which I don't have some type of security device on, then my blast radius becomes even worse, right? And so how does that really work, right? Like I said, a traditional L2, L3 architecture. We have a simple ASIC, right? We're doing fast switching, right? I'm doing I'm trying to get from, at Ethernet 0 to Ethernet 2, right? I could have two users that are trying to talk to each other. And it's very simple, right? I'm doing line rate. I might have some access control list that is involved, right? In some way, shape, and or form. I'm trying to do something, like I said, very simplistic, right? From a security infrastructure. Now, whether or not I have a cloud provider that's trying to do a ZTNA solution or on-prem, right, I still have that L2, sprawl, right? I'm in the same broadcast domain unless I'm trying to proxy everything back out and try to and come back in. So I'm not really having the L2 segmentation that I really need unless I'm putting in, some type of access control list there, right? What happens when I bring in a zero trust everywhere solution and I start bringing a secure switch path and I start bringing software defined, segmentation in? Well, same thing, right? The user comes on. Now we can actually check to figure out the compliance of that user, the compliant entity behavior, right? I can give a confidence score, right, that this particular user can get to where they need. But notice how its traffic is very directionalized with that, right? I'm not just necessarily looking at, a sprawl of traffic having implicit access everywhere. What happens if this particular device has suspicious behavior, right? For instance, it's doing something it shouldn't be doing. Maybe I'm sending out more TCP packets, or I'm sending out a type of request that it doesn't normally see. Well, then I would end up going through that secure switch path yet again, right? To be able to say, okay, where am I starting? Where am I stopping? Where am I failing at? And can I potentially, see if the traffic is benign or malicious? Traffic's benign, so we allowed it to go to what resource it needed to go to and also get to its printer. But what happens when that device is not compliant, right? Maybe I saw something from the traffic side of the house that was absolutely malicious. Maybe the user dropped their firewall. Maybe they didn't do their antivirus upgrades or something of that nature. Now I can absolutely stop this particular device at the switch level, or at the switch level. I don't have to have a blast radius, right, that encompasses the entire facility. I'm absolutely doing this on one single device. What's really cool about this, which you'll see in a couple of slides later, is how we can get analytics, for that particular device. But to kind of talk about the architecture on the switch side of the house, this is where we introduce a smart CPU, right? That smart CPU built into the switching architecture, not doing this from a separate solution, right? As Dan talked about, having a separate stack, gives us the ability to say, packet comes in on E0, right? It goes to the smart CPU. That smart CPU on the switch now becomes a policy enforcement and policy decision point where I can start making determinations on from a next-gen firewall or stateful inspection, right? Maybe I'm doing something with full feature QoS, right? Not just looking at generic buckets, right? Being able to label that packet and understanding exactly what I need to do with that packet. Above all else, it's doing the ZTNA side as well. It's actually making the determination on whether or not I am a valid user and I'm allowed to be onto that network. right? So like I said, I talked about software-defined segmentation. Everything that we're doing is software-defined from that smart CPU. So once again, let's look at it in action, right? So let's say that I have a user, right? It's online, it's fully compliant, right? It's kind of doing what it needs to do. So now at the end of the day, I'm able to get to my data center apps, my SaaS apps, and even my public apps, maybe YouTube or something like that. Wait a minute, device fell out of compliance, right? The score kind of degrades, right? Maybe that user just dropped their firewall, right, to do something. Maybe they're trying to access a certain website or something of that nature, and the firewall is now blocking them. Well, I consider that dangerous. So I can actually real time block them to maybe the data center apps while still allowing them to get to their SaaS and public apps. SaaS apps were depending on, something like a Workday or an SFDC, right, to be able to block them, based upon what they're doing. We're depending upon that security architecture to do that. But realistically, my most critical apps are still in my data center or maybe even in the cloud in AWS or Azure or GCP, right? So what happens when we have suspicious behavior and the score degrades further? Well, once again, real time, we can block them from getting to important things. Even our SaaS app, we don't want data exfil. But this is where it comes in, like I talked about, getting deeper analytics. Now that I can block the user directly on the switch itself, I can easily come in and say, hey, maybe I can grab real-time analytics. Maybe that device is trying to upload something to their private Dropbox, to box.com, something of that nature. It's data exfil. I'm seeing this as suspicious behavior. And instead of me trying to look back into the logs, right, maybe I'm having to bring in something like law enforcement or however, but instead of me looking back into the logs, I can keep this device online and I can continue to garner threat intel from that device and understand exactly what it's using without the concern and fear that this is going to propagate east-west across my switch or even across my entire network, right? So I reduce that sprawl, I reduce that blast radius, right? And I'm absolutely able to bring that to bear. So like I said, traditional segmentation off of a switch, right? Usually we will have, whether it be servers or whether it be users, right? We'll create VLAN 10, right? We'll also create VLAN 20. We have them out. Traditional segmentation says bring in an L3 point, right? Start having these together, right? Start having those L3, layer 3 access control list, somewhere on the switch. Maybe that's being delivered through a downloadable ACL. Maybe that's being delivered, through an SGT or something like that. But it still is at that layer 3, kind of mode. Software-defined segmentation, right? And this is where we're saying is a little bit different and what we should be doing, right? Versus, NAC and kind of looking at re-architecting the entire network and so forth, is that a zero trust everywhere solution should be able to fit into the network as it always has, right? But be able to, regardless of where the user is, right? Whether they're remote, whether they're on site, right? Whether they're in multiple different offices, they're always traveling, should always have a layer 7 type solution, right? Or a layer 7 policy that follows that user across the board everywhere. So now we can logically put them in segment 1, segment 2, and segment 3 without having to overhaul and re-engineer our local LAN, right? So now we can keep our same IP addressing schemes. We can keep our same level of segmentation from VLANs. This gives you the ability to rapidly adopt a ZTNA type solution while also being able to maintain your network architecture. So when the time comes and you're ready to re-architect that infrastructure, right, it's easy to do so without actually disturbing the security policies, right, moving forward. And this is what we're really calling segmentation 3.0, right? Segmentation 1.0 was our network-based segmentation. 2.0 was, hey, we can now tie it to identity. We can now follow some things, right? 3.0 is being able to software define this within the switching platform itself, being able to bring security as close to that end user as possible, right? And having that security follow that user, whether they're remote, whether they're on site, right? Primarily while they're on site, treating it as one zero trust solution versus treating it as multiple zero trust solutions. So a couple key things to kind of look at, right? And I'll turn it back over to Dan, is always remember the underlying network is never to be implicitly trusted, even internally, right? And that's because your location doesn't matter, right? We should always say that this is a medium that you run on. Yes, it's private. Yes, it's my infrastructure. Yes, I own it, right? But should I trust it? Never, ever should I do that, right? Because then I can have east-west propagation of malware, of ransomware and things like that. So always make sure, never implicitly trust that. Always look at the security being based on context and identity, and always apply your appropriate least privilege access. Make sure that that particular entity, that user, only gets access to the application. It doesn't necessarily need to get access to the resource, right? Obfuscate that, hide it, within the solution, right? Do not give a user the ability to start doing port scans and start running across your network. Other things to look at, right? I just talked about that contextual side, right? Use as many contextual controls as possible, right? We use IAM or IAM. We're using host posturing, right, and so forth. There are many, many more that are out there. Make sure to utilize as much as you possibly can to apply a risk value, right, to provide a confidence score to that particular endpoint to make sure that it absolutely can get to the resource that it needs to get. And the other big thing I look at too is always use user and entity identity, right, to establish trust, right? Don't just use one or the other. Use everything you can possibly get your hands on. Make sure that device is 100%, yours. Last thing I'll leave you guys with is make sure everything in the world is being monitored, right? We want to make sure that no anomalies are there. Don't miss the forest for the trees, right? Let's always make sure to dive in, find the indicator of compromise, right? Find it very easily in every ZTNA solution, and ZT Everywhere is profound for this. It does try to give you simplistic logs to be able to find that indicator of compromise and be able to remediate it as quick as possible. Dan, like I said, I'll turn it back over to you and let you have closing thoughts.
All right, thanks, JT. Appreciate it. So before we move into questions, I just wanted to give you our one slide commercial for Versa. Really, this is more a concept, kind of what we talked through today about trying to expand the concept of zero trust across your entire enterprise. And so, but let me tell you a little bit about Versa, just to make sure you understand where we're coming from and our point of credibility here. So Versa, we're an industry leader in unified SASE, right? And we have thousands of customers globally, and we offer a comprehensive suite of SD-WAN and security service edge products, including Versa Zero Trust Everywhere. So this is part of our security suite under SSE, and part of an overall and larger unified SASE solution portfolio as well. So we've got extensive experience in delivering zero trust around the world. We're a Thunderdome capabilities partner with the U.S. Department of Defense, and we're helping them move to their zero trust architecture. So we've got some chops around this stuff. Versa Zero Trust Everywhere provides a single ZTNA solution across both your remote and on-site workers with a single point of management and policy, right? And so there's some really valuable TCO benefits to that, as we talked about, as well as kind of visibility across your entire enterprise, right? And it lets you really significantly improve your security posture. So if you're looking at implementing zero trust, we'd love to have a chat with you to see how we might be able to help. So I think there's a link on the page that you could click, or a QR code, and get in touch with us. We'd love to chat, right? Now with that, why don't we move on to questions? Matt? Did we lose Matt? We may have lost Matt.
Dan and John, apologies. For some reason, when I try to come back off mute, it is a really, really tough ordeal, and I'm not sure why. But
I stabbed the button about 5 times before it clicks.
Yeah. No, that being said, so we've got one question sitting in. I'm going to go ahead and review the Slack a little bit to see some of the stuff that might have come through, but we've got one question sitting in the Q&A, and does Versa require any agent on the endpoint devices in order to check for identity and posture?
So I'll take that, right? So we do and we don't, right? So we can do simple 802.1x. That is, comes off your NIC, right? You can still define that like you would any normal NAC solution. To get to deeper analytics, though, we follow pretty much what the industry is doing right now, right? And there is a proprietary agent that does go on. We do have one of the most lightest weight agents out there. It's not bloated like the rest of the industry, where you have to constantly put plugins and more plugins and more plugins to do it. We do bake everything into one agent, right, moving forward. But to answer the question, simply is, yes, there is an agent, right? It does garner all of that information, right? The good thing about it is our solution makes the decisions, right, at the switch level, right? So it's not really doing a lot of processing, hence the reason why the lightweight. It doesn't do a lot of processing actually on the endpoint. It's there to more or less gather, right, and then do the authentication piece and pass that up.
Gotcha. All right. Excellent. Another question, and I'm pulling it from multiple different sources here. So everyone out there who's watching, obviously we've got the Q&A in Zoom, and we've got Slack as well. Excuse me, we've got Slack as well. So feel free to bring up questions that way. However, another one that's come in, if you're doing zero trust on site, how do you handle IoT devices?
Easy, right? So from an IoT perspective, we do have fingerprinting technologies built into our solution, so we can actually see the endpoint. Now, what's really cool about what we do, which is a little bit differently than what the industry is actually kind of moving toward right now, is that we're not just using static signatures, right? So we've actually do have proprietary solutions built into our platform that allow us to actually see the type of traffic that an IoT device will do. It will learn that traffic, right? But what it will do is it will actually match up to certain signatures and be able to help evolve those signatures like over time to say, if let's take for healthcare, for instance, if I do have a MRI machine, right, that's 20 years old, I may not know that MRI machine, but I know what the traffic of an MRI machine looks like, right, and what types of systems it needs to go to. So it will learn that. It doesn't necessarily for an IoT because they are very, I would say, simplistic, right? A lot of them run some type of Linux kernel. They do, a very specific task at the end of the day. So it's easy for us to learn what that device is, or even fingerprint that device if we have that, definition within our database, and then also segment that device accordingly. Only give that IoT device the ability to talk to whatever its manager is, right? A camera, for instance, talking to the recording system, an MRI device talking to the head-end computer, right, where it's sending the images, things like that. And in operational technology on plant floors, we do the exact same thing. So we really work right across the entire IoT spectrum, right, and across the OT spectrum, being able to deliver a secure solution.
Awesome. Very detailed, John. I like that. Really good approach. And I like how you started off with yeah, of course we do. Absolutely.
Yeah, of course.
Another one that's come in. What are some examples of how your customers are using micro-segmentation?
All right, I'll take that too. Damn, I'm taking all the questions now. Look at that. It's kind of varied, right? It all depends on what the security policy, right, for that end customer is. So without getting into way too much detail, I know we're getting ready to come up on time too. So it really does depend, right? Like I said, what that customer really is trying to achieve. I've had customers that are looking at doing micro-segmentation, doing multi-tenant type solutions, all right, whether it be on the switching or even on the edge. They're looking at taking PCI compliant devices, putting them in their own logical solution or their own logical network, right? Segregating them from the entire network, right? Utilizing segmentation 3.0 to be able to, basically say, hey, I'm PCI compliant because I'm not necessarily holding on to certain data, and it almost looks like it's air gap. I've had them look at it from a dynamic standpoint. What they will do is they will look at the Active Directory. They'll come in and say, I'll take multiple different groups, right, depending on how that user is defined. I can be able to bulk that into the solution. I can define what you need to have access to. And from that point, right, we don't talk east-west. I'm not allowed to talk to my neighbor on switch 1 port 2. I'm only allowed to talk to the application in which I'm getting to. So, and then that policy follows them, right, whether they're remote or on site, right, primarily if they're on site. I'm only still allowing that particular user to get to where they need. So segmentation, right, really does kind of come across the board. We can conform to even what traditional segmentation is. If I need to give a user network-based access, an IT user, something like that, that's easy, right? We can easily grant that. But realistically, I have a lot of my customers that are looking for something very much more targeted. And then, of course, seeing how we can conform to that.
Got it. I love it. We are right at time. John, Dan, thank you both so much for this awesome overview. Really glad to see what y'all are doing over at Versa, and I'm glad that our attendees got a chance to see what was going on and get a walkthrough as well. For a quick note for everyone, there have been some more resources for Versa posted in the Slack channel. Particularly, it looks like a blog post written by Dan. So some cool stuff going on there. But guys, thank you both very much. I appreciate you joining us today, and feel free to hang out in the Slack and keep answering questions as they come up.